So just as after a quick poll launch, we've only had it for about 30 seconds here, but it looks like we're actually pretty split. Well, we have about 30% of us coming back from other sessions. So awesome. Congratulations. Big welcome back. Love to see you guys here. And then we have about 43% of us who are here for the first time. So if you're one of those 43%, big welcome to your first event. Again, this is AR/VR for Training and Education Meetup Group. So let's go ahead, given that I always get really excited in the intro, then I'm always a little long-winded. Let's go ahead and get through the introduction quickly so we can get to the awesome stuff that Grigory has to present as soon as possible. So quick introduction, Andy, I'm going to pass the mic over to you. Maybe we can give a quick intro, then Kacey, we'll love to hear from you next.
Awesome, thanks, Tim. My name is Andy. I'm the Director of Technology at KairosXR. We focus on building training and custom VR and AR solutions for a variety of companies. With that, I'll pass it over to Kacey.
Hi, everyone. My name is Kacey Weiniger. I focus on marketing, growth, and product management at KairosXR. Really excited to be here, excited for our speaker, and to meet a bunch of you here.
Awesome. And I'm the Director of Design and co-founder of KairosXR as well. But with that said, this group is actually completely separate from KairosXR. This group has its own separate mission. It's about the community, a community of knowledge sharing. So what we found after being in the VR, AR space for years now, the three of us that is that it tends to be a little insular. There's no reason to sell VR and AR, for example, the vision or how it can be implemented, the value added or workflows within VR, because everybody gets it. Everybody's really excited about it. But with that said, there is a gap between the industry experts, non-XR experts, and then the AR VR professionals. So what could we do? We thought about it. What could we do to bridge that gap? How can we bring XR enthusiasts, XR professionals into a space with non-XR folk, but they have their own industry expertise? And then what kind of conversations and collaboration will emerge from that bridge? So that's what this group is all about. It's about knowledge sharing, it's about resource sharing, and it's about information sharing around technologies and adoption best practices and processes, and generally sharing industry expertise. So how do we do that? Again, if you've been here before, which about 15% of you have been, which is awesome, we have quite a few of these presentations. In fact, that is our core event type. But with that said, 2021 is going to be an amazing year because it's about design jams and game jams and more of that collaboration and general work, projects, collaborative projects, if you will. Hackathons is another example. So those are some of the events. And by the way, we're always interested in feedback. So that's a nice little transition to our bottom point here. So if you have any event ideas, please let us know. We always have this event bit.ly link, the feedback form that is. So if you have any ideas as to how we can optimize these events, other event types, or by the way, if you just like to say hello and continue the conversation, definitely fill out that event form and let us know what you're thinking about. We have a few other resources for you as well. First of all, relatively recently announced and launched is the newsletter. So we've launched a newsletter entirely dedicated to AR, VR for training and education. Who would have thought? Big surprise. But that newsletter is dedicated to bringing you all the events that are related to training and education, any kind of announcements. If you have any questions specifically that you'd like to ask an XR professional, you can get them answered there. And again, it's a general resource for you to learn more about AR, VR in the context of training and education. And lastly, if you meet somebody interesting, or perhaps you have something that you'd like to offer the community, we built up this form exclusively dedicated to the community. It's the event contact list. We'll drop that in the chat as well. Kacey or Andy, if you haven't already, if you wouldn't mind doing so, that'd be great. But again, it's an opportunity to put your contact information so you can follow up with some people in the group, or they could follow up with you. All right, shifting over, because we read from right to left, apparently. Shifting over, we have some upcoming events. So if you found value in this event, we certainly encourage you to come back to a few more. In fact, we run these events every 2 weeks. The next up will be March 10th. It's going to be XR and eye tracking. So how is eye tracking actually used in the context of AR and VR? How is it used to accelerate knowledge transfer, the general learning process? Ultimately, how is eye tracking implemented now in training and education? So we're bringing in an eye tracking expert March 10th, and perhaps arguably the most important topic in the world. maybe in parallel with the pandemic, of course, being diversity and inclusion. So we're going to have a diversity and inclusion expert coming in, and specifically how they've built up custom solutions to support those initiatives. These solutions all revolve around making a more inclusive workplace, soft skills training, safety training as it pertains to compliance and behaviors, corporate behaviors, but also using virtual reality and augmented reality to reduce bias and racial discrimination. So a really exciting topic there. If that tickles your fancy, as they say, come on by April 7th. We're going to have another great event. And if you'd like to continue the conversation, we have some contact information at the bottom as well. Always excited to connect on LinkedIn. Feel free to drop any of us an invite. We have the bit.ly links at the bottom here. And then, of course, you can shoot us an email directly with any specific questions if that's your preferred medium. All right. With that said, let's go ahead and dive in, people. So, we're talking about aviation training. We're talking about how AR and VR are actually used in aviation training. So again, as a primer, we start with the what, the when, and then kind of the why. Like ultimately, why are we looking at this? Why is it so exciting? And why is the entire space ripe for disruption? So we see three core areas. And Kacey, quick heads up, I'm going to pass it over to you just for a second since you found so many awesome examples. But we see a wall of text as the three core areas. First of all, aviation staff training, let's just clarify. It involves both commercial and military. It's not just about military, even though that VR has been used for military training for so long, which is exciting because that presents many more points of acceptability and points of introductions, if you will. So it's also worth clarifying that this is about early students, but also seasoned pilots. I mean, we see really multiple stages. I mean, the entire process of training potentially being impacted and disrupted with VR and AR training tools. But also would like to clarify that on ground personnel and cabin crew are also using this. VR pilot training revolves around three core areas: equipment familiarity, scenario repetition, and high intensity decision making. So what exactly does that mean? Well, first of all, equipment familiarity. How do you actually use the equipment? What equipment do you use? How do you interact with it? So going through those repetitions. Scenario repetition. So being in very rare, perhaps dangerous, unique scenarios, and then developing actually the practice of going through and becoming more comfortable and more familiar with those specific conditions and scenarios. And then the last bit here is high intensity decision making. So what happens when you're in a dangerous scenario and you have a few decisions to make? Let's imagine that you, out of the blue, you need to land on the Hudson River. Well, wouldn't it be nice if you could go through that many, many times? And actually, we do have an expert on pilot training in the audience, Cameron. So if you do have, Cameron, I see you in there. So welcome, by the way. If you have any questions about pilot training, I certainly recommend that you pull Cameron aside because he, again, really interesting conversations there. And then the last bit, if I can go back, is the prioritization of fidelity. So again, to accommodate design needs around very specific decision making, equipment familiarity, prioritization of fidelity, both physical and visual, is very, very important. So what does that mean? Fine-tune interactions with the equipment is an example of both fidelity, but also high interactive fidelity. Remote live coaching, and of course, designing and building rare and dangerous scenarios. So if you don't take anything away, take those 3 points away. Again, aviation staff training across the board, equipment familiarity, scenario repetition, and high intensity decision making as it pertains to VR pilot training. And then lastly, that prioritization of fidelity, not just visual fidelity, but physical fidelity as well, as we might see in a flight sim. So with all that said, Kacey, since you found so many outstanding examples here, why don't you go ahead and take us into some of those examples?
Awesome. So I'm just going to run through some examples. Oops. Thanks, Tim. Going to try and go through this really quickly so we can get to Grigory's talk. Just to start off, we have more of a traditional pilot simulation, just to show you kind of the traditional approach, which I'm sure many of you are familiar of. And basically, if we go to the next slide, Tim, we have different.
If I can.
Yeah, if you may. We have some examples of VR trainings, and these are both pilot trainings. On the left, we have one where Lufthansa partnered with Samsung. So this is an example of a mobile AR training experience. It was being used to help the pilots train for cross-country flight and identify key landmarks along the way. And then on the right here, we have a VR experience by Airbus. You can see the one person is using the Valve Index, which is a tethered VR headset. And then you'll see they're also in a multiplayer experience, so they can train with others who aren't actually there with them. And the other person you'll see is using a Oculus Rift S, which is also a tethered VR headset. And Tim, if you could move on to the next. Here we have some examples of training for the crew as well as the ground operations. So on the left, we actually have some examples of AVIAR, which is Grigory's company. So he'll be showing you some more detailed videos, but just as an intro, you could see extremely high fidelity experience, which he'll be diving into more of. And on the right, we have a training experience for cabin crew by AVIAR. And here you can see she's wearing an Oculus Quest. Completely unintentionally, we're getting a look at many, many different pieces of hardware right now. And then Tim, over to the next slide, if you can. These are our last two examples. So here, these are some interesting examples. On the left, we have a student wearing a Microsoft HoloLens, which is actually an AR headset. And if you look closely, sitting next to her is actually a virtual pilot. So traditionally, they would bring in a real pilot to train with her, but in this case, they were able to simulate it with a hologram. And then on the right here, we have a military training. This is for the Air Force, and they're basically learning how to do maintenance on different aircrafts. Traditionally, they would bring in the aircrafts, although this is a way more accessible and cost-effective way to do that. And here he's using the Vive Pro. Again, you're seeing many different pieces of hardware. And then Tim, if you can, over to the next slide, just to reiterate the core areas that Tim mentioned. He went into detail, so I'll just give another recap here. So we have aviation staff training, which involves both commercial and military, which you saw in the examples. We have training for early students who are just learning, as well as seasoned pilots. And then we have the cabin crew training, the ground operations training. And then within VR pilot training, we have some core areas there. Equipment familiarity, what are the different pieces of equipment and how are they used, how are they maintained over time? Scenario repetition, so what is the experience like on a flight, and if there's a risky situation, how does someone react, which is also related to the high intensity decision making. And then lastly here, to accommodate, as you saw in the quick demo by AVIAR, which will be in more specifics soon, VR teams prioritize fidelity both in interactions as well as visuals in order to create the most effective training for aviation. So again, thank you everyone for being here. I'm gonna pass it over to Andy to introduce our speaker for today.
Awesome, thank you, Kacey. Today we have an expert in VR training and aviation. He is the founder and CEO of AVIAR out of Amsterdam. He's an XR industry expert, visionary, and VR evangelist with more than 15 years of experience in high-end 3D visualizations, real-time interactive rendering, as well as mobile and enterprise software development. So with that, please welcome Grigory Rodionov. And Grigory, as you're taking over the screen share, if other folks have questions during your presentation, we encourage them to drop those questions in the chat, and we will have time for a Q&A at the end. So with that, Grigory, the screen is yours.
Thank you very much, Andrew. Okay. So hello, everyone. My name is Grigory Rodionov. I'm the founder and CEO of AVIAR. First of all, big thanks to KairosXR for such a great event and an invitation to speak. I'm really excited by this opportunity, and let me first introduce myself and AVIAR in a couple of words. So we are based in Amsterdam, and our main focus is VR training in aviation. Actually, the simulators have been widely used in aviation since almost 100 years ago, but only for pilots training. But aviation is not only the pilots. There are tons of very important jobs on the ground, around the plane, and in the plane also. And the flight safety and the airport operation safety and efficiency depends on how well all those guys are trained. So thanks to virtual reality, today we can create amazing simulations and training solutions for all ground staff, cabin crew, and many others. Because VR gives us the freedom to recreate literally any type of working scenario, not only sitting in a cockpit. So as we love to say, we can start think out of the cockpit finally. So me and my team, we started our career in XR field about 8 years ago as an independent studio. Maybe you heard about Tango Interactive company. And we've developed a lot of VR training projects for railways, oil and gas, other industries. But in 2019, we've decided to focus on aviation industry only, and to create a very specific company, which is speaking on the same professional level language with the aviation industry experts, and understand its pain points and demands. Because we believe this is the best way to create a available professional grade VR training product to combine the XR professionals and professionals from aviation field. So, oh, I want to change my slide. But I can't. 1 second. Okay, I need to minimize this window. Sorry for that. So, is it works?
Yep, we can see 2 slides, 2 by 2.
2 slides. Oh, yeah. Okay, like this. Yeah, as I said, AVIAR established in 2019. And today we are about 20 people in our team. And most of them are XR professionals, developers, and designers, and many other people. So, of course, we partner up with experts in aviation. So almost 2 years, Twiga Aero and Airline Ground Training Institute is our partners for knowledge and expertise in aviation. And they have almost 50 years of experience in ground handling and other areas. And what's more important is that members of Twiga, they actually were involved in the creation of main modern air transportation industry standards like IGOM and IHM while working at IATA in the past. So they are ex-IATA members, workers. And of course, I can say that every big client, every big project for us is a great source of very important insights. So here are some of our clients on this slide. Okay, so let's go to the main topic of our today's presentation. So one of the most important questions we asked ourselves in the very beginning is, what is the real purpose of VR training in aviation? Of course, VR training can be used in many cases. Let's say you can use it during classroom learning as highly engaging material, or you can use it as a standalone method of training, or something else. But we quickly realized that the most valuable and profitable way of utilizing VR training is a virtual practice, because this is where the cost effectiveness is easily recognizable. The return of investment is, not a question at all. Everyone understands that very well. And actually, this situation is not only in aviation. In many industries are the same situation, and the virtual practice is really, really a great thing. So imagine you've trained a bunch of young people in a classroom, and now it's time to go to the real world with the real planes, which cost hundreds of millions of dollars each. And the situation on apron is completely unsafe. So with VR training, you can start their practice in classroom environment, which is 100% safe for students and for equipment. And you don't even need to grant any access to deal with the guys from security department and so on. So the idea is pretty clever and clear. But there's one thing you should deal with during the implementation of virtual practice. You need to achieve enough realism in your training scenarios and training environment, so it could be used instead of on-the-job training, instead of conventional practice. I know that in many VR training concepts, realism is not very important, because very often they are designed very close to e-learning. It's like when you have limited interactivity, a lot of text, a lot of simple tests, like you have a question, you have an options to choose, and let's say gameplay is like more linear. It's fine when your goal is to explain something, but virtual practice has only one critically important characteristic. It has to be as close to real practice as possible. And if you really intend to replace OGT with VR, you should be extremely close to real life and highly detailed. So actually, once you achieve that level of realism, this is where the magic moment happens, when let's say the CEO of the company wearing your headset, trying a couple of things in this simulation, and it's like, oh my God, it's so real, we will buy it. So it's like great selling point, because these good CEOs, they worked as a ramp agent in the past. They know all this shit from inside, and once they see it in VR, how realistic is this, and it works the same way, that's the moment of truth. They know that it's really not a game anymore. Actually, this is how we see our main mission in VR, is the creation of hyper-realistic VR training for aviation. And when I say realism, it's not only about the visual fidelity or even 3D models detailization. It is more about how we can interact with virtual environment and get the realistic responses from it. About non-linear gameplay, when you can choose what you will do after another, and what's more important, when you do something wrong, you will get the realistic consequences, including equipment failure, damage, liquid spills, airplane shutdown, procedure failure, and also realistic reactions from your virtual workmates. So everything is described above. It should be simulated as separate systems and somehow connected to work together in some sort of the main simulation. So I want to pay attention to this word simulation, just a couple of minutes. Okay, let's change. our slide. So simulate or emulate. There is actually two well-known concepts, or maybe not so well-known, but they exist. And I want to explain the difference. Actually, emulation and emulators is about exact copying of internal structure of the device of the system with respect to all internal algorithms. And the complexity of emulator is equivalent to a complexity of the real system. It looks like it's great to have an emulator of any system you want to use in your VR. But because of the complexity, actually, there are three main cons, actually. First, to build the emulator, you need to know everything about internal design of the device. And sometimes it's very sensitive information, and you will never obtain it from the manufacturer or from even reseller, because it doesn't have it at all. Second is it's too complex, and if you want to run it on a standard PC, you will have very quickly you will have a problem with performance. And third, it's really hard to maintain that scale of the system with a reasonable business case for that. So that's why here comes a simulation, very popular concept, and actually 99% of things you see, softwares, things you see around your simulations. And the simulation is the process of mimicking the behavior of the system or an object. It doesn't matter actually how your simulator architecture or internal structure designed. The main thing you care is about that any available inputs to this system and will get their corresponding realistic outputs, like a real object. And the simulator, with simulator, you decide how complex your system or simulation, what kind of limitations you have, how many real cases it will handle, how precise it will be. And so you have a lot of freedom here. So how we build our simulations. Actually, I think it's not something unique. It's a very general approach used in many other software companies and many projects. But anyway, I think it should be interesting. So first of all, once we have the training scenario, we define the training goals. And based on that, we define the simulation components, because let's say if you have a scenario about water servicing of the airplane, you don't need to simulate other system of the airplane. So you select the system you need to simulate, and also you divide the systems for critical and non-critical. You analyze, optimize, and finally, you're ready to build the mathematical model of this simulation. This is, I think, the most complex and important part, because here you will need a really smart guy who will turn your block schemes to a mathematical equation. And once it's ready, once you understand how it works on the theoretical level, you'll start to program it and connect it to different 3D and other assets in your software. Let's go to some examples. So let's say we have a scenario of aircraft lavatory tank servicing. This is actually a very important scenario. I hope you understand, because there is a lot of guys, young guys in airports. They start their careers with this type of job, and because of the lack of training, they can easily catch a shower of the so-called blue juice from the plane. So it's really bad thing. I think they all remember the smell of this thing and how it happened. So to avoid that, we can train people in VR. So what is simulated in our lavatory tank service in Malta? First, aircraft lavatory system, but not the complete system, because there is a lot of things from, let's say, from cabin side and from outside. So we need to simulate only a few physical aspects, and also the most important components, like the tank, valves, actuators, a service panel with all the switches and indicators, and that will be enough for us. Next, we need to simulate water servicing truck with the panel, with the control panel, with the hoses, with the lifting platform, with the pumps and everything, and attach it to our mathematical algorithm, which calculates the amount of liquids in every part of the system, including the liquid which contains in the hoses, because if the hose is long enough, it could contain a lot of liquid, and if you will not wait until the return suction process, you will spill this remaining water on the ground, and sometimes it could be very dangerous, because if it's, let's say, a northern airport with a cold weather, everything what's spilled on the ground will become, an ice, and it's really dangerous. And since this system is simulated, not like scripted or something very simple, no, it's simulated, then we can easily achieve the realistic responses in the cases of some common mistakes. Let's say liquid spilled, you underfilled or overfilled the tank, you contacted the aircraft, something very common, but it is simulated, and it could be, if you do the mistake, you see the aftermath immediately. Another example is the ground power unit connection. So here we simulate, again, only a part of the aircraft system. So we don't need the entire electrical system of the airplane, because in this particular training, the main goal is to train people how to operate with this panel in coordination with the pilot, because the pilot should confirm that he's ready to switch from ground to APU, and only after this confirmation you will be allowed to disconnect the connector from the plane. Otherwise, you will shut down the plane, and usually it takes about half an hour to start all the system of the plane from scratch, because it's like a very, very complex and slow computer with a very slow version of operating system. It's loads and loads and loads, and a lot of checks and everything. So it's a nightmare for every airline, because it's of course they will break the flight schedule. Next thing we can simulate is not the equipment, but the physical processes. So let's say if you have a scenario with a firefighting on the plane, because we have a bunch of scenarios for cabin crew training. And for this firefighting scenario, we designed the simulation of the fire and the firefighting. It includes many parameters like the volume of the entire plane, and how many oxygen, how many fumes, how many, let's say, smoke, how many chemicals from the extinguisher. So we count every important aspect of this process, because this volume is it's not like if you're at home and you have a problem at your kitchen, you can open the window and after 2 minutes you will have a fresh air. No, it's an absolutely different story. Of course, after a long time of the ventilation, the air will be better, but it's really important to understand what's going inside the plane during this firefighting activity. Because if you will spread the contents of the extinguisher, which is not very healthy, around you, it's not very good. So you should point your extinguisher right behind the half-open door and close it immediately. And also because you want to cut the oxygen to the air. So all these parameters in this equation, and they constantly calculating during the simulation, and you can easily recreate the situation when someone is just making a mistake, and you see how the cabin is filling with the smoke. The second thing is depressurization simulation. When, let's say, you a flight attendant and you have a problem, which is like, let's say, a slow depressurization. It's, a very dangerous situation, because it's not when all the oxygen masks are dropping down. No, they for some reason they drop in the end. So you need to be trained to recognize some indicators of this process. Otherwise, there will be a problem. And we have a simulation of this process, when after a certain time, if you not using the oxygen mask, you will see how your vision is going into a black tunnel, and you start to feel yourself like your head is like shaking. You have a doublet image and many other effects. Also, the aircraft movement simulation. So if you want to create aircraft movement in VR for a person which is actually standing in a room, we have a few tricks how to simulate it with the movement of the gravity vector in VR. Okay, let's go next. Next important thing to simulate is physics, which is actually built in many modern 3D engines like Unity or Unreal Engine. But as many developers knows that it's so tricky thing. Look at the picture, you see a very simple thing. It's just a cart with a bunch of chocks and safety cones. If you will recreate it based only on built-in physics, and you will start your stacking your cones one on another, after 3 cones, you will have the problems with the chaotic collisions inside bodies of these cones. It will cause a lot of bad things in your simulation, and it will be like a crazy thing. And the same with the chocks. You just can't put it just like a normal physical objects on the surface, because they will never act like you want it, because you will be tired by adjusting these friction components and other components. So if you will do everything with built-in physics, you will have a lot of problems. I want to show you one example how the built-in physics behave when you do something wrong. Just 1 second, I will switch to this video. So this is the recording of the screen during one of the tests, internal tests of our scenario. And you see that the tow bar is completely disconnected from the tug and the plane because of the extreme tension, which is caused by the actually bad implementation of the physics in Unity. Actually, built-in physics in many engines very far from scientific simulation of physics in some, let's say, scientific software, because you try to optimize it, you try to make it work on any computer, so it's so much optimized, so it never works accurate. Okay, let's go back to presentation. Just 1 second. Okay. Next thing is interactions. So in VR, we have virtual hands. Sometimes it's controllers, sometimes it's your own hands with hands recognition systems like leap motion or built-in Oculus. But anyway, your virtual hands somehow need to be coordinated with your real hands. And of course, it is impossible to build this interaction the same natural way like in real life. One of the interesting cases I have here on screen is the headset and the wire and the button and the jack on at the end of this wire. So in real life, it's so simple to wind the wire, to put the jack in your pocket, to place the headset on your neck or on your head or in your bag. So you can do a lot of things, and it's like you never think of it like a complex thing, like a complex task. But in VR, it's a challenge because, okay, so actually I can't do all this stuff with my virtual hands. So I need to invent something to operate with this simple thing like in real life. So we have invented our own interaction method with such type of object. I wish I will show it on video, but I will not this time. We'll try to explain. So we have a wire which behave in relation with the state of the object. So let's say if you work with a controller, with the Vive controller, you have a small button above the trackpad. So once you press this small button, your jack is in the pocket. You press it one more time, you grab the button. You press it one more time, it's like everything disappeared. You have no wire, you have only the headset itself. And also you can put the headset on your neck, on your head, by just, you place the headset near your neck, you see the text on neck, headset on neck, and you just release it and it's on neck. Or you just place it near your head, you release it, it's on your head. So it sounds simple, but it takes a lot of time to invent something simple and natural, which the same way works very close to the real thing. So this is one of the examples. And one of the greatest insights during these experiments I had is that sometimes best interface is when there is no interface at all, because people, they want to train their future job. They don't want to train to work with VR, or they don't want to train with some sort of fancy interfaces. They want to do it like in real life, and to pay attention to some job aspects, not to like control the experience. So this is very important to understand, and very important to remove all these barriers between the technology and the training. Okay, I think I'm done. And if you have any questions, I can also show you one more video, which I forgot to show.
All right. Well, thank you, Grigory. While you're pulling up that video, I think it's great to have some additional content, so go ahead and pull that up. While you're pulling that up, we actually are curious to see who is attending. This will help us guide some of this Q&A. So Tim, timely drop of the poll there, perfect. So let us know what you do, and that will help steer kind of the QA. For those who've dropped questions in the chat, it's been extremely helpful. I've captured those, so we're gonna try to cover those. We're gonna spend the next 5 minutes for a Q&A, and then that'll bring us right up to the end of the hour. If you're willing to stick around afterwards, you have time, we'll go into our standard breakout rooms then to continue the discussion. But with that, Grigory, why don't you pull up that additional video that you have?
Yes, 1 second.
What a great presentation. Really appreciate this.
Thank you. No, it's not that. Oh, that's it. I want to show you the moment when the person, the trainee, he forgot to turn off the pump. And let me just fast forward. So he forgot to turn off the pump and start to disconnect the hose. And immediately you see the circumstances. Okay, so the valve is closed, but the pump is on. And oops, whoa, the water is all around. So it's really important to give people opportunity to learn from mistakes and to see really the realistic aftermath of any mistake. So yeah, I think.
Awesome, great. And while you were doing that video, we did have the poll go out. It looks like the majority of folks attending today are AR and VR professionals. So with that said, we had a few questions come in about the development process. And so I'm curious to ask you, how do you source your 3D assets? You mentioned photogrammetry, CAD models, modeling. Curious how you are getting those assets for these applications. And similarly, with the development process, how many people are typically working in one of these simulations?
Okay.
And then how much access do these folks actually have to the real environment to base that?
Okay, actually, good question. I want to show you one more time this page. This is actually the page, the great page to comment to accomplish my answer. So first, 3D assets. We do everything from scratch. We never use any stock models, or we never get complete models from someone somewhere. It is always completely from scratch. We use photogrammetry, laser scanning, video recordings. If we can find some technical drawings, we use it a lot. Very good thing is maintenance manuals. And of course, if it's possible, we try to get the support from the manufacturer, but it's not always possible. And the reason is that the original 3D models and drawings from manufacturers, they are actually a subject of trade secret. So not very often manufacturers willing to share such documents. And also it's a very long process. So for us, it's much easier to get the information we need different ways, especially, let's say, the engineering level 3D models from manufacturers, they contain a lot of details we never use. So it overcomplication of the process. So it's much easier to have good lasers scan to make a model from it. The process is really smooth. Next thing is the simulation. So to build the simulation, as I said before, if it's not the emulator, you don't need the access to the actual algorithms or to the brains, to the firmware of the actual device. For you, it's like a black box. You don't have to know what's inside. You have to know only what kind of inputs you can create and what outputs you should receive in accordance. So the main sources for us, it's operating manuals, maintenance manuals. We do a lot of video recordings with the multiple GoPros during operations. It's like, one GoPro is sitting and then looking at the control panel very closely. And another GoPro is on the head of the worker. One more GoPro is on the panel of the car, and in all the important areas, and they all rolling simultaneously. And we in the office, we combine all these videos into multi-screen video with the synchronized videos from all the cameras, and we see the process from many angles. It's really helpful to understand how it really works, what's the behavior of this piece of gear. Also, of course, very important, interviews with the workers, with the technicians. They have a tremendous experience. They know everything from inside, how it works. Sometimes they know more than manufacturers because they know some, issues which occurs after, manufacturer released the product on the market. And of course, if it's possible, we try to get the information from the equipment manufacturer because it's the best way, because they will explain in some form how it works, and it's like information from the source. So that's it. It's the first question. And the second question is, how many developers? As I said, we have 20 people in our team. But they are split into the smaller teams, and usually the team, about 5 to 6 people, work on a single scenario. So that means that, but sometimes for very, very complex scenario, we combine 2 teams into one team, bigger team, just to develop it faster. So that's it.
Awesome. Thank you. So I know we are right at time, folks. We do have one more question though I'd love to get your answer on. So we're gonna just continue on for another couple of minutes. One last question. You mentioned that, along with the videos, capturing multiple angles, interviewing folks that are working with the equipment. So those are the subject matter experts. We had a question come in wondering how you confirm the training application's accuracy. So I imagine this goes back to the subject matter experts, which would mean that You interview them up front along with those videos, and then you probably bring them in throughout the process. Can you elaborate on where the subject matter experts fit into your process?
Yeah, very good question. Yes, actually, the most important part of the development process is the testing of the final simulated scenario. In this process, should be involved all the parties. So developers, the client, and the experts from the client side, and our experts and advisors. They also should try it many times in different modes. They because they have a lot of experience and they catch something. But sometimes it's not enough time to catch a very rare bug in your rare bug in your software. For this case, we have a warranty. That means that if it will happen during the implementation of our software, we will fix it for free, because we understand that the complexity of the system is really high, and maybe we missed something important. It could happen. So we have a warranty for our software, and we will fix it for free. Yeah, but the testing process is really long and really important, and sometimes we test it during a month, in every day. So yeah.
Yeah, awesome. So it sounds like bringing in subject matter experts for an extensive testing period. On top of that, including a warranty that says if we miss something, we'll fix that, which means that you're standing by the software that you're creating, which is fantastic. I know we're at time here. We have one last and important question for you. If folks want to follow you, how should they stay in touch? What is the best way to follow and keep up to date with your progress?
Well, actually, in our previous years of the operation, we were so busy, so we didn't pay enough attention to all the social media things and our accounts in the different places. But we will fix it very soon. But right now, you can go to LinkedIn, to my page, to Facebook, to our page of AVIAR. We have also have a website, which is actually not very detailed. There is not that much information. We prefer to send the detailed presentation directly to the client. Also, I have my own account on Facebook and LinkedIn and Instagram. And we plan during the coming month, to put a lot of new stuff into our social accounts, because we have a lot of new scenarios, which is absolutely, never presented in any platform, especially cabin crew training, which is an exciting area. Because I think maybe I'm wrong, but time will show. But maybe it's even a bigger thing when ground handling, because there is a certain business reasons for that. Because we expect the recovery of the aviation. It will start this year. And I think the most intensive process will be next year, and the full recovery in 2 years. So that means that a lot of airlines will be calling for new stuff, and they will need to train new stuff. So I think it could be a tsunami.
Yeah. Sounds like you have a little bit of room for coming up for air now, as far as getting the social platforms going. But hopefully, we all hope that it picks back up and things can return to some sort of normalcy. But to answer the question, it sounds like Facebook and LinkedIn and Instagram are the best way to follow Grigory. So if you would like to stay in touch, that's the best way to do that. Grigory, yes. Again, thank you. Amazing presentation. And with that, I'm going to turn it back over to you, Tim.
Cool. Yeah, absolutely. Echoing Andy's point, fantastic presentation. Do you want to clarify? We had a few questions that we didn't get to. We'll do our best to get to the answers to those questions. We actually have a new initiative launching where we'll have blog posts, follow-up blog posts that answer each question that was dropped in the chat. So if you have a question and it wasn't answered in this session, know that we'll get there, and then we'll have a follow-up blog post to answer it very, very soon.